Welcome to Bot Thoughts by Soft. I'm Alex, and today we're tackling something that nearly every team building production retrieval systems hits eventually. You spent 3 months wiring up a beautiful RAG pipeline. Vector store, embeddings, reranker, the works. And then a user uploads a PDF that's mostly tables and charts, and your retrieval falls off a cliff. Joining me is Sam. Sam, multimodal RAG, what changed in the last 12 months that suddenly everyone is talking about it?
A few things converged. ColPali came out of the Iluan technology team in mid-2024 and showed that you could embed page images directly with a vision model and beat traditional text extraction pipelines on document benchmarks like Viduri. Then Cohere shipped Embed v3 Multimodal. OpenAI added image embeddings to their newer models, and Voyage and Gemini followed. Suddenly the building blocks were commodity. The other shift is on the consumer side. Users are uploading screenshots, slide decks, scanned invoices, and they expect the chatbot to find the answer regardless of whether it lives in body text or in a chart on page 47.
Let's level set for listeners. When we say multimodal RAG, what are we actually retrieving, and what changes versus the standard text RAG most people have built?
Standard RAG is a one-modality pipeline. You chunk text, embed each chunk into a single vector, store those vectors, and at query time you embed the user's question and find the nearest neighbors. Multimodal RAG widens that pipeline. The corpus can include images, page screenshots, video frames, audio, even tables rendered as images. The embedding model has to project all of those modalities into a shared vector space so that a text query like "Show me Q3 revenue by segment" can retrieve a chart screenshot, not just the surrounding paragraph. And the language model that generates the answer needs to be vision capable, so it can actually read the chart you handed it.
The default approach for years has been throw the PDF at a layout-aware extractor like Unstructured or Llama Parse, get text back, embed the text. Why is that not enough? It's been working fine for plenty of teams.
It works fine until your documents are visual first. 3 failure modes I see constantly. First, charts and figures. The OCR pulls the axis labels and maybe a caption, but the actual relationships in the chart, the trend line, the comparison between bars, none of that survives extraction. Second, complex tables. Multi-row headers, merged cells, nested groupings. Even the best layout parsers butcher these. Third, scanned documents and screenshots. OCR error rates compound. By the time you've embedded the noisy text, your retrieval is hallucinating before the LLM even sees it. The Viduri benchmark showed text extraction RAG losing 15 to 20 points of NDCG on visual documents compared to direct page image embedding.
Let's spend some time on ColPali because that paper got passed around so much last year. What is it actually doing differently?
ColPali skips the OCR step entirely. It takes a page screenshot, runs it through a vision language model, the original used Polygemma, and produces a multi-vector representation per page. Crucially, instead of squishing the whole page into one vector, it produces one embedding per visual patch, somewhere around 1,000 vectors per page. At query time, the text query is also tokenized into multiple vectors, and you do a late interaction match between query tokens and page patches. That's the same trick Colbert introduced for text. You get fine-grained matching. The word revenue in the query can light up the specific patch of the page where the revenue chart lives. Storage is heavier, but with binary quantization you can keep 1,000,000 pages in commodity hardware. The other thing worth highlighting is that ColPali is bilingual by design. The vision encoder doesn't care what language the text on the page is in, because at the patch level it's just visual features. Teams running multilingual document corpora have reported that this is actually one of the biggest practical wins, almost more than the chart treating ability.
1,000 vectors per page sounds expensive. Walk me through the storage math. If a team has, say, 100,000 internal PDFs with 5 pages each, what does that actually cost?
500,000 pages, roughly 1,000 vectors each, that's 500 million vectors. At full FP32 with a 128-dimension projection, you're looking at around 250 gigabytes. That sounds like a lot, but with binary quantization, and ColPali was designed for this. You compress to about 16 gigabytes. Qdrant, Vespa, and Weaviate all support binary multi-vector indexes now. The query latency overhead from late interaction is real, maybe 30 to 100 milliseconds extra at P99 on warm cache. The honest answer is, cheaper than you'd think, but you absolutely need a vector store that natively supports multi-vector and binary. Don't try to cram this into PG vector, you'll cry.
ColPali is one approach. What are the alternatives, and when would a team pick something simpler?
3 other patterns I see. The simplest is hybrid. Extract text the normal way, but also embed each page image with a single vector model like Clip or Cohere embed v3 multimodal. At query time, you fuse the 2 scores. This is cheap and gives you a meaningful lift on visual queries without the storage hit. Pattern 2 is image as document. Skip text entirely, embed each page as one vector with a strong vision encoder. Then at retrieval time hand, the top K page images directly to a vision-capable LLM like GPT-4o, Claude, or Gemini and let it read them. This is what teams are doing when they need to ship in a week. Pattern 3 is structured extraction. Use a vision model up front to convert charts and tables into structured JSON, then embed the JSON. More work, but the JSON is queryable in ways an image isn't.
How do you actually evaluate a multimodal retrieval system? Text RAG eval is hard enough. Adding images feels like it multiplies the problem.
Honestly, this is where most teams fall over. The first move is to build a domain-specific eval set. Take 50 real questions your users have asked, manually annotate which page or which figure contains the answer, and then measure recall at K-Viduri is a great public benchmark, but it doesn't reflect your invoices or your SEC filings. Second, separate retrieval eval from generation eval. If retrieval is broken, no model in the world will save you, and conversely, a perfect retrieval can still feed a hallucinating model. Third, instrument production. Log every query, every retrieved page, every final answer, and sample for human review weekly. The teams that ship reliable multimodal RAG aren't smarter, they just have better eval discipline. The other piece of advice I give, track your eval set version over time. As your corpus changes, and as users ask new kinds of questions, your eval set should grow. Stale eval sets give you a false sense of stability when your real-world recall is silently degrading.
On the generation side, which vision-capable LLMs are actually good at reading dense documents in 2026, and where do they still fall down?
Claude Opus 4 and Sonnet 4 are remarkably good at reading tables and small text in screenshots, and the Anthropic models are unusually careful about not hallucinating numbers from charts. GPT-5 and the O-series are competitive, with the reasoning variants particularly good at multi-step questions over multiple pages. Gemini 2.5 Pro has a 1 million token context window, which lets you stuff 50-page images into a single call, but the longer the context, the more you see attention drift on the middle pages. The honest weakness across all of them, handwriting is still rough, multi-column layouts with footnotes still confuse models, and any chart with a non-standard axis, log scale, dual y-axes, invites mistakes. Always verify numerical claims out of the model.
If a team wants to ship a multimodal RAG system this quarter, what's a reasonable stack? Don't list 10 tools, give me the opinionated default.
Opinionated default for late 2026. Document ingestion. Use a layout parser like Unstructured or Reducto to pull text and bounding boxes, but also save the raw page images. Embeddings. Cohere embed v3 multimodal for the single vector path, or ColPali via the Bialdi library if you need maximum recall on visual content. Vector store. Qdrant with multi-vector and binary quantization enabled, hosted or self-hosted, both work. Reranker. Cohere rerank 3 multimodal can rerank a mixed list of text chunks and page images. Generation. Claude Sonnet 4 by default for cost-quality balance. Escalate to Opus when the question requires multi-step reasoning over 5+ pages. Observability. Log structured traces with Langfuse or Phoenix. That stack will get you to a working demo in a week and a production system in a quarter.
What are the failure modes that surprise teams in production once they ship.
3 big ones. First, image quality drift. Users upload phone photos of contracts, screenshots of screenshots, faxes from 1998. Your retrieval pipeline needs a normalization step. Deskew, denoise, upscale, or quality variance will torpedo recall. Second, mixed language documents. A French invoice with English headers or a Japanese technical report with embedded English code samples. Most multimodal embedders have an English bias, and that shows up as a sudden recall cliff for non-English visual queries. Third, version drift in the corpus. Documents get updated, screenshots become stale, and your index keeps returning the old version. You need a reindexing strategy and a last updated filter. None of this is exotic, it's just operations work that nobody puts in the architecture diagram. And one more I'll throw in, cost management. Vision-capable LLM calls are 5 to 10 times more expensive than text-only calls because each page image consumes hundreds of tokens. If you're handing 5-page screenshots to GPT-5 for every user query, your bill will surprise you. Build a cheap text-first path and only escalate to vision when the retrieval scorer says the answer probably lives in a figure.
When should a team not build multimodal RAG? When is it overkill?
If your corpus is markdown documentation, code, or chat transcripts, text-native content, multimodal is overkill. The complexity tax isn't worth it. Same answer if your users are mostly asking factoid questions that already work with keyword search plus reranking. The good test: take 50 real failed queries from your existing system. If most of them failed because the answer was in a chart, a table, or a screenshot, multimodal will help. If they failed because of poor chunking, ambiguous wording, or missing data, multimodal won't fix any of that. Solve the cheaper problem first.
Sam, final take. An engineering leader is listening on their morning walk and they want one concrete action for Monday. What is it?
Pull the last 100 user queries from your existing RAG system. Manually classify how many failed because the answer lived in a chart, table, or scan page. If that number is over 20%, schedule a 2-week spike. Hybrid clip plus your existing text embeddings, top K page images handed to Claude or GPT-4o for generation. You'll have data on whether multimodal moves the needle in your specific domain before you commit a quarter to it. Cheap experiment, real evidence, no architecture astronaut energy required.
That's the playbook. If this episode helped, subscribe wherever you get podcasts and consider supporting the show at buymecoffee.com/amticsoft. Next week, we're tackling small language models in 2026, 5.4, Gemma 3, and whether you should be running models locally instead of paying per token. Thanks for listening to Bot Thoughts by Amticsoft.